Okay, greetings, Mr. Ari. In this opportunity, us Swiftex will present our final project on optimizing the queue at McDonald's TBC Matupang. My name is Raisa Kamila, here accompanied by my partners Raisa Tifali, Albert, Deva, Salsabila, and Zahwa. Okay, before diving into our project, we actually did a literature review on this, the modeling system in which intends to simulate real-life events into systems. This application is also applied in various sectors such as manufacturing and service. Here are the methodology that we use to conduct the literature review. And from the methodology, we conducted a review for 30 journals. These are the distribution based on the countries and sources. Also, the distribution of the tools mentioned from the 30 journals. Okay, from the prior information, it is known that there are 62% of fast food restaurant that uses this to solve their problems. However, there are three main project gaps that we analyze. The first one is that there are still sectors that don't use this. The second one is that the DES application in Indonesia is not distributed well. And the second one is the application of Simio software that are still not yet having much exposure. Keeping our final project in mind, we conducted the pros and cons of this application, and we concluded into three recommendations, which is to implement a more discrete data, to apply alternative data sources, and to measure the level of simulation in other countries.
Problem definition. Next. Here we had proposed for the company that we would like to analyze for this project. It would be McDonald's. McDonald's Samsung is one of the leading fast food companies in which McDonald's would be mentioned. And also McDonald's has some ordering options, including from dine-in, takeaway, delivery, and also the drive-thru. And McDonald's drive-thru system in Indonesia is released in 1995. And one of the most crowded drive-thru traffic is McDonald's Tbc Matupang. Hence, we had analyzed the voice of customers of McDonald's TBC Matupang customers, and then we had analyzed them and classified them into the scenario which people are queuing up at a very long time in the drive-thru section, and the issue would be long drive-thru waits and also congestion, and the requirements would be a faster service time for the customers. So how can we solve this? We can utilize discrete event system simulation to tackle this problem. Then we analyze McDonald's in the terms of the industrial sector, in which we can see that from analyzing through the Porter 5 Forces framework, McDonald's is a prominent player in the food service industry sector. Next. And then we analyze using these SCQ frameworks, starting from the situation which McDonald's offers a drive-thru facility to purchase meal, and then moving on to the complications, starting from the long drive-thru, and also increasing amount of orders and also congestion, in which we can come to a question of how can McDonald's service system be improved to reduce wait times, and how can we improve the queue management to avoid the congestion. And then here are our project charters, starting from the business case, the goal statement, which is to improve McDonald's service system, the scope of problem, the queuing system, and also the problem statement. Next. And then we analyze the service quality gap, starting from the first gap of the consumer expectation and management perception, service quality specification, service delivery, excellent communication, and also expected service versus the perceived service. And here is our timeline of the project, starting from the end of March to the 1st of June. And here are our action plans, which is our project goal is to offer recommendations supported with the discrete event system simulation by analyzing the drive-thru system in McD TBC Matupang, in which we had gathered 4 action plans, starting from gathering the basic data of the system, running the observation, inputting the data to the Simio, and also performing data analysis.
Okay, moving on to the conceptual models. So from our problem statement, we gather the hypotheses, which are lack of serving stations, slow cooking times, and then also lack of worker stations. Okay, from there we get our modeling objective, which are by modeling the process, we could get a clear understanding of how McDonald's TB Simatupang operates. Therefore, for the observation, we have some assumption and also limitation. So for the assumption, which are the service time in each step is the same. Every order is the same combination of food and drinks, and then for waiting by duration, we count that as the pickup order time. And then for our limitation, we we would only observe the drive-through portion of the process, and then this model will cover what is typical and will not cover variance due to the demand of fluctuations. And then these are the simplified model of the real-world McDonald's drive-through. So these are our bullseye diagrams. We divided into three, which are the exogenous, superficial endogenous, and then also endogenous. So for the entity entering the system, which are cars and motorcycles, and for our three queuing system, which are ordering area, payment area, and then also food pickup area. Okay, and then these are our flow chart, starting from the entrance and then last until pickup and exit. And then for our framework, which conclude the control mechanism, is staffing level, shift scheduling, and then also operational procedures. And then for our inputs, the experimental factor, which are arrival rate, queuing system utility level, queuing time, and then also service rate with the output or the response of distribution test, data validation, cost scenario, and maximum utility and entity rate, which for our external variable, including the operational procedures, special events, and then also promotion, our stakeholders, which are employees, customer, governments, NGOs, and then also McDonald's competitor, and our shareholders are McDonald's franchise owner, and then also stakeholders. These are our scope of work, which conclude McDonald's main layout, which are order, payment, and then also pickup.
Okay, thank you, Chacha. So moving on to model construction. Next. From the conceptual model, as Chacha has said before, we have the problem statement of issuing arising while running drive-thru services and also miscommunication of orders and payments. Our limitations are observing our drive-thru portion only, and also the model will cover only what is typical. And the quick question we want to answer is, how can we improve queue management to avoid congestion in Mc? Next slide, please. So our objectives are improving to reduce wait times and also improving queue management to avoid congestion. Our observation is conducted at TB Simatupang and over 1.5 hours. Next slide, please. So from this table and the table in the right, we have arrival rate on our time. Next slide, please. And also payment time and also pickup time. All of these are normally distributed because they have a probability plot of bigger than 0.05. All of our observation data is normally distributed. Next slide, please. So our observation is visualized here, and we have an experiment time of 1.5 hours. Next slide, please. So we have modeled our model in Simio, and we also have the entity of cars created 26 and also destroyed 26. So for the order area is 52%, payment area is 37%, and pickup area is 47% for the utilization rate. Next.
Okay, so after constructing the model, we create a model validation. Next slide, please. So first, we conducted an animation validity where we compare our animation process flow with our conceptual model, and we came into the conclusion that our Simio model is validated based on the existing occurrences. Next, please. Next is phase validity, where we compared our conceptual layout and Simio layout, and we can see that our Simio design represents the layout and flowchart according to the conceptual layout. Next, please. So here's a table of each layout of the conceptual layout, and we see that our model has constructed each 5 of them. Next, please. And here is the event validity, where both our observation and Simio model starts at the same time, which is 12:37 minutes. So next is the output validity, where we compare our Simio model and observation input based on the average time in station and entity, and then we compare them into ratio, and then as we can see in the representation part, all of them is more than 95%. So our Simio model has successfully represented the real life situation. Next, please. So we can conclude that our Simio model has been adequate in showing how McDonald's TB Simatupang operates its drive-thru.
Okay, next is the solution that our group has created to reduce waiting time on McD TBC Matupang drive-thru. Next, for the first solution, we changed the layout from the drive-thru to enter from the right and exit from the left, and we added one order machine to speed up customer placing orders. But with the solution, one additional kiosk machine and workers are required. Next. For the second solution, the same as the first solution, we changed the layout from the drive-thru to enter from the right and exit from the left. In the second solutions, one machine is added and the machine system is replaced. The machine can carry out orders and transactions in the same machines, so customer can pick up via QR code. But customer will want to pay with cash and do at the pickup area. And the solution also add one location pickup area, and the solution requires an additional 2 workers. Next. For the third solution, we mostly use the same layout, but we add pickup area because the biggest waiting time is in the pickup area. With the solution, an additional 3 workers are required. Next. The fourth solution is to add one machine and replace the machine system. The machine use will be the same as the machine in the second solution, where a customer can make payment using QR code. Using the solution requires the additional of one worker. Next. The following is the formula for processing time used in CMU from solution 1 until solution 4 using random normal distribution. Next. Due to limitation in the data we have, we assume the current state of TBC Matupang McD is 0 rupiah, so the following are the costs of adding machines, building construction, and etc. We got this data from the interview with handyman, IT workers, and Google. Next. So from the result of the cost comparison solution 1 until 4 that we have made, we conclude that solution 2 has the most cost to replace all layouts, and solution 3 has the least cost. But we still need to analyze other things before determining the best solution. So from result of 100 and 1000 application, we get the result of time in system and number in system. It can be seen that solution 1 has the best number in system with the second lowest cost. So from the remaining solutions, solution 1 has the highest quality from the overall solution. So the best solution is to implement the solution number 1.
This would be the lesson learned from our solution model. So based on our analysis, alternative 1 would be the right solution, since it has reduced the service time with a gap of 104.716 seconds, and it costs around 16.5 million. So how can alternative 1 be suitable? Because alternative 1 has successfully reduced the service time, and it offers the second least cost. It also, the overall utilization percentage results only has a small gap in compared to the initial layout. So lesson learned through the project that we had conducted this semester would be, it has 3 main events. Starting from the observation of McDonald's is solely for academic study purposes and does not imply any support for unethical actions, in which we should clearly communicate the intent and scope of the project, and hence we need to include a disclaimer in all project materials stating the study's purpose. And for managing time constraint, we should implement more efficient time management strategies, and we need to implement dashboards to track progress alongside personal and also group schedules. For addressing financial data deficiencies, we should improve data collection and analysis techniques. And then we need to hold regular progress meetings to identify and address the bottlenecks. And here are all of our appendix. And that would be it for the presentation from Swiftix. Thank you, sir, for listening.